Hello wonderful person, this is Anton, and in this video we're going to discuss a relatively complex but somewhat intriguing new study that basically presents us with the first ever image of what an actual photon potentially looks like. And unlike previous older studies and previous older videos that essentially showed us what the light might look like as it travels through various objects, this time we get to see a single photon based on some really complex modeling and recreation, and based on what we understand about electromagnetism and quantum physics. And so let's talk about this in a little bit more detail, but I guess let's start with the basics in regards to light itself. Because as many of you already know, light is really bizarre. It's basically both particle and a wave, with a photon being an object that doesn't actually contain any mass, yet is still able to push on things because it does contain momentum. It's also one of the few things out there that's able to move at the maximum possible speed, the speed of light, and for many decades has never really been imagined in a way we can actually understand it well. Because sometimes it's presented as a particle, sometimes it's presented as a wave, but never as something substantial or something we can imagine without making conceptual mistakes. And although mathematics can explain light very well and can even easily represent it with a certain formula, when it comes to real world, or I guess real life, unfortunately there is no analogy we have in order to help us picture what a photon might physically look like. And to date, one of the best visualizations and approximations has always been the wave function, or essentially rules dictating the boundaries for a photon, but also the rules on how it influences its environment. And here this is really important because a photon by itself is never really alone. It always influences everything around itself, and so for example everything we see around us with our eyes results from the exchange of energy between various atoms and various photons through electromagnetic forces. And so in some sense the scientists behind this recent study refer to it as a kind of electromagnetic conversation, a very complex interaction involving electromagnetic forces that usually involves a lot of different electrons constantly influencing various photons, absorbing and releasing them in the process. And so the main premise for this new study that you can find in the description, and here this is a study by Ben Yuen and Angela Dimitriadou, was to basically come up with a kind of a framework in order to explain the interaction between light and matter at a quantum level, and to basically establish various quantum interactions between atoms and photons, focusing on the geometry and the optical properties of the environment, and the effects all of this has on the propagation of photons, including how they change their shape, color, or how they can even exist. So just to rephrase this, imagine a photon interacting with a single atom. Here the idea was to see how the actual quantum effects change over time, not just for one interaction, but for multiple interactions as the photon travels in some kind of a material, and as it affects a lot of atoms around itself through various quantum effects that we are familiar with. Here the scientists refer to this as photon's non-Markovian trip, and a trip through time and matter. And so in order to understand these quantum rules of travel, the two scientists behind this paper developed a new model that then describes how light particles, or how photons, engage with atoms of silicon after one of the photons is emitted by one of the atoms. So basically here the model explains the propagation of a single photon from its starting point all the way to the end. And while in the actual study, they present this through various graphs, basically capturing the propagation of light and discovering how it changes over time. But to their surprise, while they were doing this, they discovered that there was also a kind of a noise that was produced in the numbers inside their model. And specifically, by studying the intensity of the field surrounding the photon of light, which essentially represented the difference between total intensity and the decrease of intensity over time, they actually discovered that all of these photons were leaving a kind of a footprint. Here it's referred to as quantum footprint, or a kind of a quantum wake that at first appeared as noise as these photons were traveling. But turns out all of this noise could then be interpreted and even combined into something else. By studying these wakes, or these footprints, it allowed the researchers behind the study to then visualize how these wakes were produced, or what was producing these wakes and these footprints. So basically they were able to produce a kind of an outline of the object, and it looked like this. So in essence, this unusual byproduct of their model allowed them to physically produce the image of a single photon by studying the footprints in these quantum fields. and this has never been done in physics before, and by itself is a huge achievement. Now obviously this is not a physical photon, and this is also not a picture of a photon, but it does represent a quantum object that interacts with various atoms near it, leaving behind energy footprints. And so essentially the model that was only focused on the interaction between photons and atoms of silicon, completely by accident discovered the photon's outline, revealing its shape in the process, and in this case revealing it with a lot of detail. And so assuming that the model is correct, and assuming that this is confirmed and reanalyzed by others, this is a huge breakthrough. Not just because this looks cool, but also because in some sense, by being able to precisely calculate how photon interacts with matter around it, we can unlock a lot of new technologies, including the concept known as nanophotonics. Here, this usually relates to various types of secure communication, detecting tiny viruses, controlling very complex chemical reactions, and basically a lot of other stuff you can learn about in one of the links in the description. And trying to do something like this has actually been a challenge for physicists for several decades. So in some sense, this is a groundbreaking discovery, assuming it's correct. With this image being way more impressive than anything we've seen before, including previous experiments that basically showed us the so-called light in a bottle. I actually wanted to briefly mention this just for a comparison. It's based on that famous experiment from 2011 by the scientists at the MIT that created a new imaging system that was able to acquire 1 trillion exposures per second, with the camera basically capturing the light as it traveled through the bottle. And actually more recently, the scientists from the University of Toronto turned this into a kind of a multi-view perspective by using AI tools, which allow them to visualize everything from different perspectives. You can learn about these achievements in some of the links in the description, but here this was an entirely different technique. Here this is basically a single laser producing several pulses at once, which are then captured from different angles by first observing the reflections and then trying to figure out what the trajectory was through complex computations. And so every single frame in this video is basically a different laser blast, which then creates a single video. In contrast, in this image, we're not seeing anything real, but instead what we're seeing are the energy levels, specifically the quantum energy levels, produced by a single photon as it interacts with silicon particles around it. So in some sense you can think of this as a photon's ghost. Although obviously here it would be super cool to see this in motion. So maybe these two teams could collaborate and create something even cooler with that Coca-Cola bottle. Anyway, so definitely a potentially super important research, but where exactly this goes, we don't really know yet. The model itself is definitely interesting, but it's still super theoretical and doesn't actually have any physical applications yet. But once there are some updates, or someone else comes up with something else really cool that looks amazing, we'll come back and talk more about this in some of the other videos. Until then, check out some of the previous videos on physics in the description below, subscribe, share this with someone who loves learning about physics and other sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.